The purpose of all of this find a maximum, find a minimum garbage isn't just to make pretty pictures. The purpose of doing L'Hopital's rule over and over is to find a limit, but it's also to find that long-term behavior. It's to look at what our real life applications turn into. So all this max and min stuff now gets the wonderful joy of being part of real problems. Word problems. Yay. So like our related rates problems, the hardest part of that is doing the setup for the equations. I need to know what the equations are. I'm going to build a box, an open-topped box, like a shirt box or a gift box. I'm going to build it with a piece of cardboard. That means I have to fold up pieces, right? I need to know where to make the folds to make this box hold as much as it can. What's the biggest box I can make out of this particular piece of cardboard? Volumetrically, the largest volume. Maybe I wouldn't use this particular piece of cardboard. Let's be a little more specific here. I'm going to take a 3-foot square piece of cardboard. And I'm going to cut the corners so I can make the folds. I'll leave the little flaps so I can tape them, but I need to know how big the piece is to cut out of the corner. So let me see if I can figure this out. I'm going to be a slight bit more pedantic here. When I say cut the corners, I mean to cut a square in each corner. So I'm going to cut a square in each corner. That's going to leave 4 little flaps, which I will then fold up. I'll use the leftover bit from the square to tape it to the other side, and I'll get a box. I'm a very visual person. Let's make some pictures. I have a starting picture. Looks like a square. I end with a box with an open top that I can see into. But in order to get from here to here, I have to make a cut in the corner. Like that. And then I'll have fold lines here. So far, so good? I have no equations. I need to find some equations because my goal is to find the largest possible box. That's something I want a maximum from. If I want a maximum, ignoring the fact that I'm dealing with a piece of cardboard in a box, if I want a maximum, I need a critical number. I need to either make a table or to use the second derivative. Somehow I need to test whether or not that's a maximum or a minimum. Hopefully it's a maximum, and then I'll know. But I need a function to do that with. And that function needs to be a function of one variable. So now the question is, in this scenario, what's the thing I have control over? How big the square is, right? This little cutout I make in the corner. Now, if I want a box that ends up with a square bottom, then I should make those cutouts the same size. Otherwise, my box is going to be lopsided and not very well put together. We'll make them all the same size. I need a variable. I don't care what you call it. You can use any bloody letter or symbol you want. I need to know what we're calling the cut we make. How long is it? It's a name for that. Length. So I'm going to call this distance right here. I'm going to call this L for length. Advantage. It's the same all the way around. So each and every one of these lines is the same size. They're all L. Now, shift to the picture on the right. I have a box. Formula for the volume of a box. Length times width times height. Volume is length times width times height. Great, wonderful, fabulous. That doesn't have squat to do with little l, does it? But I could make it have something to do with little l. Because I'm folding this thing into this thing, right? So the length of my box, capital L, that'll be the length of this piece. That's this right here, isn't it? Ah, so the height is little l. What's the length? Say that again, Adrian? But 2 little l is the part that we cut out. I need to subtract 2l from something. How big was the cardboard to begin with? Aha! What about the width? Because it's going this way and it's the same idea. Great. Which means I have a formula for the volume of the box that is a function of one variable, the variable L. The volume in terms of little l is length times width. They're the same thing, so I'll just square it, times height. Ta-da! Now, reality sets in for a moment. And I say to myself, hang on a second, I want a box. There are some limits to the size of thing I can cut here. What is the smallest possible cut I could make? Zero. Here's my box. What's its volume? So that's dumb, but I could do it, right? That's a lower bound. I could cut nothing. So I can even add to this that L must be bigger than zero. What's the biggest thing I could cut? All of it, which would mean I make that L exactly in the middle. I cut away 1.5 feet on the left and 1.5 feet on the right, and I have, again, a box with volume 0. Hey, I want to find the maximum value of a function on a closed interval. Didn't you just do this for homework? You know what to do. Please do. Take a derivative and do what with it? To find the critical numbers. Test the critical numbers and the ends of the interval. Thank you. It's up to you to decide what level of algebra you want to do up front versus the algebra you want to do at the end. You could leave this function just like this and take the derivative just like this, or you could multiply it out and take the derivative that way. Because if I square this out, L for L squared, I get 4L cubed minus 12L squared plus 9L. That's a polynomial. It's easier to take the derivative of. No chain rule, no product rule. It's easier to work with that way. What's my derivative? Avery, talk to me. It's a problem. Shaking your head like that. I'm like, what the hell did you just do? Talk to me. I want to know that one. All of those things are divisible by 3. I'm going to factor out a 3. And now you have your choice. Because I want to set that equal to 0 or figure out where it's undefined for my critical numbers. It's a polynomial. It's never undefined. All I have to do is set it equal to 0. You can either factor it or you can use the quadratic formula. Well, if I do the chain rule and the product rule, I can. I absolutely can. But then I'm going to have to set it equal to 0, right? So I'm going to have to multiply it all out anyway. So do I do the multiplying out beforehand or do the multiplying out afterwards? I can do the squares fairly easily, but there'll be a lot more combining of like term, and I'll have to do the square anyway at the end if I do the chain rule, because there's a product rule in there as well. I figured it was easier to do the multiplying out first, but you're absolutely correct if you want to do it that way. You should end up with exactly the same numbers in this spot. I rigged this problem. This does factor. But if you're looking at me and going, how did you do that? Feel free to use the quadratic formula or look at the X factoring method or splitting the center term, all sorts of different options on how to factor. I have two critical numbers. Notice that one of those critical numbers is also the endpoint of my interval. The interval goes from 0 to 1.5. 1.5 is one of my critical points. Hey, it gets to do double duty. I'm sorry, say again?
Why does L equal half?
Well, that would give me a volume of 0. And a volume of 0 is a well-defined number, right? It's a dumb box, but it is a volume of a box, right? This box holds nothing. How many Olympic gold medals do I have? 0. That's a valid answer. And until they make teaching an Olympic sport, I'm never going to get one. Probably won't even then. What do I do from here? I want the highest and lowest values. This is a closed interval. All I have to do is plug and test. Now, the advantage, I think, is that when I write out the function in its before I multiplied it out form, I can see really easily what happens when you plug in 0. I'm going to get stuff times 0. That's 0. When I put in 3/2, I'm going to get 0 squared. That's going to give me a 0. The only one that should give me, I hope, a non-zero answer is 1/2. Aha. 3 minus 2 times 1/2 squared times 1/2 is 2 squared times 1/2. 4 times 1/2 is 2. 2 what? Oh, wait a second. What are my units at the beginning of this problem? Feet. But that's still not the right unit for this. What are the units for this measurement? Feet cubed. Because it's feet times feet times feet. Have I answered the question we were asked? Why not, Nicolina?
No. What the heck?
I did do that. Say again?
Yeah.
It said, find the volume and the dimensions. I've only found the volume. Volume should be 2 cubic feet. I need length, I need width, I need height. But I have the formulas for LW and H earlier, right? 3 minus 2x, 3 minus 2x, sorry, 3 minus 2L, 3 minus 2L, and L. So I know the height is 1/2 foot. And I know the width is 3 minus 2 times 1/2. And I know the length is the same thing. 2 foot by 2 foot by 1/2 foot tall. I don't know if you're ever going to be in the business of making boxes. I doubt it, but I could be wrong. But I don't know what scenario you're going to find yourself working in. My goal is to be able to find the optimal solution for whatever setting you are in. And the process for all of these is the same each and every time. Page 336. Steps in solving optimization problems. The first one, understand the problem, is often the hardest one. Read the problem through carefully. Make sure you know what is being asked. Because the worst thing you can do is finish all this work and not answer the damn question. What am I looking for? What was given to me? What are the conditions involved? What are my restrictions? Make a picture if it helps. Even a crappy picture helps sometimes. You don't have to be an art major. Just give me something. Put notations, just like with our related rates. Things that change should get notation. Things that I don't know about should get notation. Especially the thing I'm trying to solve for should get a variable. Turn it into one variable. The one thing I want to know about, because there are ways to do calculus in more than one variable. That's Calc 3. We're not there yet. And that's this step right here. Reduce everything. Use given information to find a relationship between the variables you've got. Turn it into one variable. Once you're in one variable, find me a maximum, find me a minimum. You're done. Use that to answer the question. But literally, any situation works. A question that was asked first formally in the 1700s. What is the best way, the most efficient use of space to pack balls into boxes? I want you to build me a display of oranges at the grocery store, working in the produce department, right? How do you get the most of them into the section you want? How do you stack up balls? Johannes Kepler asked this about cannonballs. He wants the most efficient way. You're gesturing your hand, Jordan. Talk to me. It's pyramided up. So let me make the job simpler. Let's not worry about 3D. Let's worry just in 2D. I want you to tell me the best way to put circles inside a square. If you were going to pack circles into a square, would you do it like that? That's how I see most cans delivered to me, right? But there's leftover space, isn't there? And if I want to make this smaller space between them, you can see that little asteroid shape there. If I wanted to minimize that, I'd offset my rows. Look at how much smaller the gap between them is between these two layouts. I've seen this before. Not just in spheres. Imagine reversing the color scheme here. Let the circles insides be white and fill in with a color the gaps between things. What does that look like? Like a honeycomb. Kepler asked this question and noticed the similarity. And this was turned into the honeycomb conjecture. Do bees know calculus? They must. They're using the most efficient way of combining space. Bees must know calculus. This problem was asked in the 1700s. It wasn't actually proved to be the most efficient packing until 2001 by Dr. Alan Ho, formerly of the University of Pittsburgh. And I wish I was making this crap up, but here's the problem in the textbook. Problem number 47. In a beehive, the front looks like that hexagon with a circle in the middle, but they mesh up in the back. They don't just cut the backs flat. They actually interleave the backs so that they use less wax. It's less work for the bees. I want to be as lazy as I can possibly be. Let me do the easiest possible job, use the least amount of materials. The angle up here at the top in the corner where the two cells come together depends on the width between the two layers. So when you look at a beehive, they've got those slats in them. A man-made beehive has those wooden slats. They're a particular width. And the bees will adjust the angle at the top there to account for the distance between the edges of the wood. The formula for that is gross as hell, but it's all in terms of that one angle. And when we find the minimum angle for this, we actually find it in real life. Useless idea. I'm never going to see it anywhere. Density packings like this are then not just used on spheres, they're used on information. How many of you have listened to a song on an electronic device today? How did it get to you? What program were you using? Spotify, Pandora, iTunes, whatever, right? You're playing an MP3 file. What's MP3 stand for? Music protocol number 3. It's really deep here. It's a compression algorithm. It's a compression to take the raw data file with all the music and squeeze it down as much as possible so you can fit that song in as small a space as possible. That's what MP3s do. That's what AAC recording does. That's what a codec does. It compresses your file so it's easier to deliver to you. All a streaming service is somebody else's computer. Can you imagine 8,000 disk drives full of music just hunting up your song every damn time? They've deposited those little compressed files so that you can uncompress them and play them. Regardless of the setting, the goal is the same. Let's figure out how I can turn this into one variable and make it work. Another one. I believe it's problem number 16. Problem number 16. A rectangular storage container with open top is to have a volume of 10 cubic meters. The length of the base is twice the width. Material for the base costs $10 a square meter. Material for the side costs $6 a square meter. The base of this is going to be in contact with the ground. I need to use pressure-treated lumber so it doesn't rot. Find the cost of materials for the cheapest such container. That's it. That's all they've given. What the? am I supposed to do with this? Hmm. Start with a picture, right? I think I understand what they're trying to get me to do. Trying to get me to build this storage box and find the cheapest cost of materials. A box with a rectangular storage container. Okay, that's an important statement. Rectangular. With an open top. So I only need to worry about 5 sides. I don't have to worry about 6. Is to have a volume of 10 cubic meters. The length of the base is twice the width. Which one's which in the picture I've drawn? Which one do you want to call the length? Which one do you want to call the width? This one is width or length? If that's length, then that's width. That's the base. And then I have a height, just like our previous box. And I know what that I just said in the problem. The length of the base is twice the width. Material for the base is $10 per square meter. Sides is $6 a square meter. What is the thing I am trying to find the minimum of? So I need a cost equation. When all is said and done, I want a cost equation. All right. I've got 5 sides to worry about. Don't have to worry about the top because it said open top. Front, back, left, right, bottom. Which one do you want to start with? The bottom? Okay. What is the area of the bottom of this box? Let me start with the letters I've got first over here, and then we'll change them out. Length times width is the bottom, right? But that doesn't give me cost. If I want cost, what do I have to do? Factor in the per square meter cost, right? So the base cost is 10 LW. That's now in dollars. Because I haven't dealt with sides yet at all. I've only done the bottom. But now if I want to do a side, which side do you want to do, Emma? Pick one. Front, back, left, right. Front, back, left, or right. Front and back. Front and back should be the same size, right? And the size of this rectangle is length times height. Front or back area is length times height. There are two of those, the front and the back. I want them both. But then the cost is going to be 6 times that. Left side, right side. What's the area? Say again, AJ? Height and width. That's this square right here. Well, rectangle. But I want them both, and then I need the cost. Now, Jolanta, you're absolutely right. Everywhere I see an L, I can get rid of the L and replace it with this. So I take this expression for the cost of the base, plus this expression for the cost of the front and the back, and this expression for the cost of the left and the right. And everywhere I see an L, I replace it with 2W. Those are now the same set of variables I gather like terms. Marvelous, wonderful, but what's the problem with this expression? I don't know H. I have two variables still. I know the volume. They gave it to me at the beginning, right? The volume is 10 cubic meters. I haven't used that fact at all yet, have I? Unless it's bullshit that they threw at me just to mess with me, I should use that somewhere. Let me go back to my picture for a second. Volume of a box. Length times width times height, right? So that 10 cubic meters is equal to LWH. Wait a second, L is 2W. I have an expression. I get rid of the H. If I take this and write it H equals, I can put that into here. I divide by 2, I get 5 on this side, so I get 5 over W squared. And that now goes here. And that's going to give me only W's. So now I actually have a cost function, a function, C of W. 20 W squared plus 36 W times 5 over W squared. Let's simplify that. Before I do that, let me parallel what I did in the previous problem. Once I had my equation, I asked about the reality of the situation. They haven't told me anything about the way this container looks, except it's twice as long as it is wide, and it holds 10 cubic meters. which means it could be really, really, really short. And really big. Like I was going to spread stuff out like a compost pile. It could be really small and very deep. Do I have an interval? Only in the fact that I know my numbers need to be positive. If my length is 0, I'm not going to make a box. If my height is 0, if my W is 0, I'm not going to make. I don't have a closed interval this time. This time, all I have is an open interval. Which means I cannot do the same thing I did last time to get the answer at the very last step. I do still need my critical numbers. I need to know where I could have a maximum or a minimum. So, take the derivative. Tell me where it's undefined. Tell me where it's equal to 0. Give me a list of critical numbers. It again may be to your benefit to rewrite this part so that you can avoid doing the quotient rule. Write that as 180w to the minus 1. Or you could put a common denominator in now and do the quotient rule. It's your call. Which calculus do you like better? Which algebra do you like better? We're going to have to do some of each all the way through this process. My derivative. (40w minus 180w to the minus 2), or 40w minus 180 over w squared. I want to know where this is undefined. I want to know where this is equal to 0. I should probably make a common denominator. If I do it here, that's just the same as if I'd done it up here and then done the quotient rule. I need a w squared on the bottom here, so I multiply by w squared over w squared, making this a w cubed. Where is this equal to 0? Wherever the top is 0. Where is this undefined? Wherever the bottom is 0. This derivative is undefined when w is, which is not part of our domain, because here we said w has to be strictly bigger than 0. That's not a critical number. I don't have to worry about it. Where is this equal to 0? That's a disgusting number. I haven't the foggiest idea what that number is. Somewhere between 1 and 2. 1.65. 1.65 what? There's got to be a unit that goes with that number. What are the units for this problem for width? Meters. We're dealing with cubic meters for volume. I've got to be meters by meters by meters. Great. Is this the width that gives me the cheapest cost? It's my only critical number, so I hope the answer is yes, but I don't know. I need to check that I actually have a minimum here. If I had an interval, I could test the ends and test this and see which one was the smallest, like we did in the first problem. I don't have an enclosed interval. Can't do that. Use the what? Ah, I can do my sign chart, right? Put this number on there. And I said I didn't know what this number was, but I knew it was between 1 and 2. Those can be my test numbers. The cube root of 1 is 1. The cube root of 8 is 2. So I knew this number had to be between these. But take this and plug it in where? That's going to give me the cost number. How is that going to tell me whether this is a minimum or not? What do I plug into in a sign chart? I plug into the derivative. So I want to plug into the derivative. That means up there at the top, right here, plug in 1 and I get 40 times 1 minus 180. That's a negative number over 1. That's negative. We're going down. Plug in 2. 40 times 8 is 320. 320 minus 180 is positive. Divided by 4. That's still positive over positive. We're going up. I'm going down, I'm going up. I have a local minimum. Did I answer the question we were asked? Problem number 16. A rectangular storage container with an open top is of a volume of 10 cubic meters. Length of the base is twice the width. Material for the base costs $10 per square meter. Material for the sides costs $6 per square meter. Find the cost of materials for the cheapest such container. I have not answered the question yet. I need the cost. So I take that number, I put it back into the original equation. That's 20 times the number cube root of 4.5 squared plus 180 divided by the cube root of 4.5. What is my materials cost? Say again? Do I hear a second? Is that value everybody else got? Or are we talking out our ass again? Hmm. First thing I'm going to do is I'm going to take this number, the cube root of 4.5. I've got that number. I'm going to store it in one of my letters so I don't have to keep typing it over and over. Now I'm going to do 20 times that number squared plus 180 divided by that number. Okay. Important. Well, now I can check the budget. Do we have enough money to actually build this thing? Or are we broke this week? I don't know. I was going to say, the end of the month is tomorrow, so I haven't been paid yet. I might be broke. But that's just materials cost. Labor cost, transportation, permitting, all this other fun stuff. Yeah. We found this was a local minimum by building a sign chart. This is not the only way to prove we have a local minimum. That is the first derivative test. What's another test that will show me whether or not I have a maximum or a minimum? It's related to concavity. The second derivative test. I take the critical number, plug it into the second derivative. It's concave up, I have a minimum. It's concave down, I have a maximum. The second derivative, we hadn't computed. But if I go back up here to my first derivative, the second derivative is 40 plus 180 w cubed. And if I do C double prime of this number, that's 40 plus, wait a minute, 180 times I'm going to cube a cube root, 4.5. I don't care what this number is. Is it positive or negative? And if it's positive, I'm concave up, so I must have a minimum. I would still have to compute the actual cost because that just tells me whether or not I have a maximum or a minimum. It doesn't answer the question, which is how much does this thing cost? Questions? Angela, what mistake did I make? Oh, yes, I did make a mistake. Good catch. That should be a negative third power, right? Which would mean that is not multiplied by 4.5, it's divided by 4.5. That's still a positive thing. Negative power goes on the bottom. More questions? frequently, the difficulty comes in setting up the equations, in figuring out what equations are needed to do the problem we're working on. Problem number 67, supply and demand. A baseball team plays in a stadium that feeds 55,000 spectators. When ticket prices are at $10, average attendance was 27,000. When ticket prices are lowered to $8, average attendance rose to 33,000. Find the demand function, assuming it is a straight line. How should ticket prices be set to maximize the revenue? I don't know how many of you go to baseball games. I don't know what you pay for tickets. I'm not going to go see the Pirates anytime soon. But this is a legitimate business question. I don't care what thing we're looking at. We have 2 price points and 2 attendances. I can make a straight line from 2 sets of data. When the price is $10 per ticket, the number of seats sold is 27,000. When the price is $8 per ticket, the number of seats sold is 33,000. A demand function is usually written price in terms of things sold. A demand function is P of X, lowercase p. What bothers people about this frequently is that it seems like the numbers should be reversed. I pick the price, I find out how many people show up. Unfortunately, that's not the way the economists wrote this, and it pisses me off. I'm not in charge of the economics department. I don't get to say this. What is the equation for the straight line demand function? What do I need to make a line, right? I need a slope. How do I get that from here? Yes, but I don't have a y, so what am I using for my y? Yeah, I'm using my price. The slope, change in P over change in X, is a very, very small negative number. If I make the price cheaper, more people come. Makes sense. This is a slope. I need the rest of it. Give me the actual equation. I need y equals mx plus b. I have p equals mx plus b. So I can solve for b with either set of data points, or I can use that point slope form. P minus one of the prices is slope x minus one of the x's. Pick one. Which one do you want to use? The 10 or the 8? Solve for b. 27,000 divided by 3,000 is 9. So B is 19, and my price equation looks like this. What does that 19 represent? Right. But that's not when P is 0, when X is 0. That's too expensive for me to go to that ball game. Period. You set the price at $19, nobody's coming. Okay. If I figure out where P is 0, that would be the tickets are free, right? And I should know the largest number of people who would want to go if the game was free. The next part of this question asks, what price should I set to maximize revenue? Revenue is price times quantity sold. P is our price. X is the number of tickets we're selling. So my revenue is X times P. Wait a minute, that's not one variable. Take the expression we have for P, put it in there. And now I have an equation of one variable. Minus 1 over 3,000 x squared plus 19x. Please tell me, what price is a critical number? And then, is that critical number a maximum or a minimum? Please notice, I'm going to get an X value, right? When I solve this, I'm going to get X values that are critical numbers. I'm then going to have to figure out the price based off of that quantity sold. My derivative is that's a line, polynomial, that's defined everywhere. I just need to know where it's equal to 0 to find the critical number. Now, before I go any further, that's my critical number. It's a maximum or a minimum. I don't even actually have to do any work to show that this is a maximum. Why do I know this is a maximum before I go any further than this? How do you know that? How do you know? Because that would be a sign chart, right? I could go up and then down, show it's increasing and then decreasing, so that's a maximum. But I haven't done that work. How do I know from right here, without doing any further work, with what's currently on the screen, I know that this is a maximum? Gotcha?
Well, I was gonna say that because of the 19.
But that's in this equation. up here, not in this equation. Emily? Now, it could have been any relationship to X, but there's something special about our revenue equation that lets me know right away that this must be a maximum. The revenue equation. It's a parabola. Parabolas either look like this or they look like this. Which one do we have? It opens down because that number is negative. But really, that's the second derivative test in hiding. Because if I take my second derivative, r double prime of x is negative 2 over 3,000. Negative means maximum. That thing we learned about parabolas was really something I learned about concavity. We just didn't use that phrase back in algebra. But now, I haven't answered the question yet. Question asked, what price should I sell the tickets for? I don't find the price. Which original equation? Dollars. $9.5 per ticket will bring in the most money to this stadium per game. I don't ask how much money will I bring in, because that would be my gross revenue, right? I didn't plug into R of X. I plugged into the demand equation, P. Find the ticket price. Depending on our situation, we may or may not have to rely on knowing things from other classes. Alonso, where did you learn revenue is price times quantity? Microeconomics. But it makes sense to me. If I'm selling candy bars, I know how many I've sold. I know how much I charge for each one. I know how much money I make. That's a fundraiser. I did those in high school. We have more of these. I have lots more examples. Guess what we're going to do tomorrow? More. I will see you all then. If you came in late and have an assignment for me, please bring it up.